Analysis of variance and degrees of freedom are two important concepts in statistical modeling, and an understanding of two concepts can help in your statistical modeling course. Today what we'll do is that today we'll try to understand the intuition behind the concepts, and we'll go through a whole lot of examples to drive home the concepts, right? What we'll do now is that I will request you to kindly watch my earlier modules on statistical modeling to understand this module better. The link will be given in the description box. So what we'll do today is that we will try to understand first the intuition behind the concept of degrees of freedom. Then we will understand the concept of ANOVA. Lastly, we will understand the concepts with the help of an example. I would request you all to please take notes while you are watching this video, because it will help you a lot in retaining the concepts. Okay, let us first start with degrees of freedom. In order to understand degrees of freedom, we need to first answer this question, that how many independent data point is there in a set of data, right? Now let us take a few examples, right? Okay, suppose we have taken this data point 2, 3 is 5, and then 5 is 10, and then we have taken 2, that is 12. Okay, now these are 4 data points, right? 1, 2, 3, 4. Then what we will do is that we will take the mean. What is the mean? 5 plus 5, 10 plus 2, 12. 12 divided by 4 is 3. So the mean of this data point is 3. Now given the mean, how many independent observations we can take in this data set? Given the mean, if we know this first observation can be anything, right? Second observation can also take any value. The third observation can also take any value, but the fourth observation cannot take any value because we know the mean. If we know the mean and know the three observations, the fourth observations can be easily found out. So in this case, these 3 observations are free to take any value. These are free. This is what precisely your degree of freedom is. Degrees of freedom is the number of independent data points is possible in a set of data. I hope you have understood what is degrees of freedom. Okay, now let us start with the concept of ANOVA. What we do in ANOVA is that first of all we have 3 or more than 3 groups or 2 groups, whatever it may be, with n number of observations, right? The concept of ANOVA is analysis of variance. Okay, we are trying to do the analysis of variance. That means the variation in the data set needs to be analyzed. That's as simple as that. So we will divide the variance into 3 parts. First of all, we will do the total variance, which is also known as sum of squares of total. So this is your total variance. Try to understand this concept as clearly as possible, because these concepts are very, very important. And then what we will do, what are the 2 possible sources of variation? One is that we can have variation within the group, right? This within the group observations there can be a kind of a variation, and there can be also variation between the groups. This group 1, group 2 and group 3, there can be variation. So we can have variation which is given by sum of squares within the group, which is W. That is within the group variation, within group variation. And then we will have variation between the groups, which is SSB, which is between the group variation. So your total variation will be equal to your within the variation group and between the variation, between the group variation and within the group variation, right? And in order to calculate the total variation or the total variation, what we will do is that we will take something called grand mean. Okay, we will take the grand mean. Grand mean is the mean of means. Okay, grand mean. We will take grand mean. First of all, we will take the mean of this group, then we will take the mean of this group, then we will calculate the mean of this group. After that, we will calculate the mean of means, which is your grand mean. So first we will start our ANOVA by calculating the total variation, which is given by sum of square of total SST. Okay, after that what we will do is that we will calculate within group variation. This is SS within, sum of squares within. Now we have calculated the grand mean, let it be X. This is the grand mean. Then what we will do is that we will calculate within group variation. So each of the group will have their own mean. So this is x1 bar, the mean of the first group, this is x2 bar, the mean of the third group, and this is x3 bar, the mean of the third group. Okay, now what we will do is that these individual observations from the group, so we will take this 2 minus x1 bar, we will square it, plus we will do 3 minus x1 bar, we will square it, plus we will this will be 4 minus x1 bar, we will square it. Similarly we will do for the second group and we will do for the third group. What we get is SSW, right? Now after we have calculated SSW, we will calculate it sum of square between the group. For that what we will do is that we will take the grand mean. Okay, the grand mean we have already calculated, which is x bar. We will subtract the group mean, which is x1 bar in case of first group, x2 bar in case of second group, and x3 bar in case of third group. We will subtract x1 bar minus x bar, we will square it and we will do it 3 times because there are 3 observations, plus 3 times x2 bar minus x bar whole square, plus 3 times x3 bar minus x bar whole square. This is your SSB. This is the between group variation. Okay, so we have calculated SST, we have calculated SSW, and we have also calculated SSB. What we'll do next is that we will try to see whether the variation within these groups are due to chance or actually there is a difference in the populations. So what we will do is that we have to calculate F statistic. F statistic is, we have to calculate, so write F cal is the sum of square between the group divided by the degrees of freedom, in this case it is m minus 1, and sum of square within the group divided by the degrees of freedom, which will be m into n minus 1. We will explain these degrees of freedom when we will do the exercise, Excel exercise, right, with the example, the same example. So we have calculated the F cal, the calculated value. So we have to see the F critical value in the F table, with here it will be for for degrees of freedom. So for degrees of freedom 1 and for degrees of freedom 2 we have to see the F critical value, and for a level of significance, that is alpha, usually it is 10% or 5% or 1%. And the rule is that if the F calculated value is greater than the F critical value, then we have sufficient evidence to reject the null hypothesis, right? And if F calculated value is less than F critical value, then there is no sufficient evidence in favor of rejection of null, right? So this is the rule that we need to follow. And after we have calculated the F value and then we have seen the critical value of F from the degrees of freedom, then what we will do is that we will try to see whether we are in a position to reject the null or we cannot reject the null. Now what we will do is that we will understand the concept of ANOVA with the help of example. Okay, we will take the example now in Excel. What we will do is that we have taken 3 groups, the same example that we have done. The observation, there are m groups and there are n observations, right? So these are the observations that we have taken, and we have calculated the mean of the each group. These are the mean of each group, and then we have calculated the grand mean. In this case it is 4. Then we have calculated the total variation, which is the sum of square total, SST, and the degrees of freedom is mn minus 1. That means we have calculated the grand mean. We are taking the difference of the individual observation from the grand mean, right? We have taken, this is the individual observation and the difference of individual observation from the grand mean. Okay, this grand mean, and then you have squared the terms, added it, and what we got is SST, which is 24 in this case. The degrees of freedom is mn minus 1 because there are m groups, n observations. So how many total observations are there? 9. So we have taken the grand mean. So grand mean is known to us. So how many observations are independent? 8, right? So we have degrees of freedom as mn minus 1. Then we have calculated within group variation by taking SSW. We know how to calculate it, right? What we have done is that we have taken the group mean and then we have subtracted it from the individual mean. The individual observations are subtracted within group, right? So individual observations are subtracted from the group mean. So this case is the individual observation C3 subtracted from its group mean, own group mean, right? And then we have taken and squared the terms, added it up, and what we got is the sum of square of within the group. And in this case the degrees of freedom will be n minus 1 into m, because there are n observations in each group and we have taken the deviation of the individual observations from its own group mean. So n minus 1, and how many groups are there? M groups are there. So the degrees of freedom will be n minus 1 into m. Okay, now we have calculated the deviation or the variation between the group. What we have done is that we have taken the deviation of the group mean from the grand mean and then we have taken it thrice. If you can recall the formula, we have taken it thrice. So we have taken it 3 times. Then we have squared the terms here and then we have added the terms and we have added these 3 terms, which is 6. So you can see that the total SST is 24 and SSW is 18 and SSB is 6, right? Now what we will do is that we will try to calculate the F statistic. So here in case of SSB, how many degrees of freedom are there? SSB, yes, this is m minus 1, then our degrees of freedom will be 2, right? So we have 2 degrees of freedom. And in case of SSW, n is 3, so 3 minus 1 is 2, 2 into 3 is 6. So we have 6 degrees of freedom, right? Okay. Now the formula for F statistics is what? This is your like SSB divided by its degrees of freedom. So SSB is what? 6. 6 divided by 2 is 3. So SSB divide, so your F statistic is equal to your 3 divided by, so it is divided by is 18 SSW divided by its degrees of freedom, which is 6, which is again 3 in this case. So what we get is that it is 3. So 3 divided by 3 is equal to 1, right? So 3 divided by 3 is equal to 1. So what we get as F is our F value as 1, right? So we have got our F value to be 1. Now let us then calculate the F value. We have calculated the F value. Then we will look into the F table. Okay, what are the 2 degrees of freedom? 2 and 6, right? So we have taken 2 and 6. So this is 2 and this is 6 for alpha 10%. This is the the critical value, the table value, right? It is 3.46. Our calculated value was 1. Our critical value is 3.46. So what we can say? We can say that we cannot reject the null, right? We cannot reject the null. That means there is no sufficient evidence, as our calculated value is much less than the critical value. We do not have sufficient evidence to reject the null. So we can tell that the variation that is observed in this case is randomly due to chance and there is no actual variation within the groups. I hope that you have understood this chapter and this module, and thanks for watching this. If you have any query, feel free to get in touch with me. Till that time, goodbye.